Hello friends, my name is Vivek Sharma. Today we can cover this interesting problem that's called word search. So in this problem we have been given a 2D board and a word, and we need to find whether that word exists in the grid or not. Okay, so here it is mentioned that word can be constructed from the letters of sequentially adjacent cell where adjacent cells are those horizontally or vertically neighboring. Okay, same letter cell may not be used more than once, right? So what is horizontally and vertically means? They can move horizontally and vertically to find the next character. That's what it means, right? And in the constraints, basically board length cannot be null. Basically it will be between 1 and 200, and board column length will also be 1 and 200, and length will be up until 1000, right? It can be till 1000. All right, so let's do this. Let's try to understand this problem from this whiteboard, and let's see, we have to find this word in this matrix, right? So how we will find this word in the matrix, right? What is the first step that we have to do? So in order to find this word in this matrix, what we will do, we will just do the same thing, whatever we will traverse the matrix, right? So we will be traversing this matrix using two for loops, right? That's how, because it is a two-dimensional matrix, right? So generally if we have to traverse two-dimensional matrix, we use the two for loops. So that's what we are going to use here as well. And using two for loops, one is for the row and another is for the column, right? So in order to do that, first character is A, so then we will be matching A with this first character in the given word, that is also A. If it is matching, then we will mark this word as a visited. Why we are going to mark it as a visited? Because we want to make sure that we are not visiting one character again and again. Why? Because let me take a step back and let me explain why we are doing this, right? So first of all, how we are going to solve this problem, right? How we are going to find this word in this matrix? One way is fine, that we are going to traverse in two for loop, right? We are going to use two for loop to traverse this matrix, and we will keep passing each character to our some hypothetical helper method, right? And that helper method will be matching each character of this matrix along with each character in this word, right? If it is matching, it will mark it as a visited and it will find the next character. How it is going to find the next character? It is going to find the next character horizontally or vertically. What does that mean? It can move any of the four direction, right? So for example, if it is F, the next character might be right side, it can be either left side also, it can be either upside, or it can be downside as well. So that's how it will find the next character. Once it finds the next character, it will move into that direction, it will mark again that character it as also as a visited, and then it will find the next character. It will keep doing the same thing again and again. So clearly the pattern here is basically depth first search. Why it is depth first search? Because at every cell it's deciding where it has to go. So it will go to the next character and then it will go to the next character. It will keep finding in one direction until it does not hit the false condition. False condition means it, if it does not match, the character does not match to the next character, for example in this case E, and we already traverse A, B, C, right? And the next character is C, so C is not matching with E, then what it has to do, it need to come back and it need to traverse the next direction, right? So probably it will, if it will go below, then it will find the next C that is matching with the second C. So that's why it is depth first search. It will keep going in the one direction until it does not hit the false condition, means it does not hit the condition that does not satisfy it, right? If that condition or that characters they are not matching, then it will come back and it will explore the next direction same way, right? So it will just go to the same direction again and again. If it does not find the next character, if the match is not there, then basically it will come back, and then basically what it will do, it will just basically explore the next direction and otherwise it will just keep going into the same direction. So that's what we need to do. Basically this is the pattern that I can think of here, right? So we were just going through this example. So let's say it's going to the A, and then it will go to the B. Let's say if it is going in the same direction moving forward here, and then B is matching, then it will go to the C. C is also matching. If it is go to E, E is not matching, then it will come back here. And C, from C we were just moving forward, right? And C we already visited as a we marked C as a visited, right? So we need to undo that visiting thing as well. We need to roll back that visiting thing to the actual character that was C. And then let's see if it goes to the downside, down direction, right? Then it will find, okay, C is matching with the second C. Then it will again go to the down and it will see, okay, E is also matching with the next character, that is E. And then let's say if it is going to the uh, either it can go right or left, right? It has to traverse in the single direction basically until it does not hit the false condition, right? Because it is a DFS, it is a depth first search, it is not the BFS. BFS, what we do at every cell, we we traverse all the available direction, right? It traverse like all the neighbors, and then it make the decision, and then it do the same thing for all other neighbors for that particular cell. But in DFS, what we do, we just go deep in one direction until it hits the false condition. Means if it hits the base condition, in other words, if it hits the base condition, means basically it has to come back, and then it has to go to another single direction basically until it hits the again the base condition. And I am assuming here the base condition is having the conditions that basically include it is either the crossing the boundary or character does not match with the given character basically in the world, right? So that is the assumption of the base condition. Similarly, if it hits here E, so E does not match with the D, then it will come back and it will undo this visiting thing. So we mark this as a visited E, but we have to undo this, and then it will go to the right, and then it will say, okay, D is matching, and then it is the end of the word, given word, right? What does that mean? If we have one counter or the index counter, then it will keep incrementing for the each character. Then we say, okay, if the word length is equal to that counter, then we will return true, otherwise we will not return true. We will keep checking these things again and again. Okay, so let's do this. Let's try to create couple of placeholders, and then I think the picture would be little bit more clear, and then we will come back and then we will try to understand or clear other doubts if there is any. So I'm not going to handle the base condition board is null here, because board cannot be null. It will be length would be basically between 1 and 200, both rows and columns length. So let's go ahead and take the variables m and n here. So let's say m is my number of rows and n is number of columns. Then basically we will have to for loop because it's two-dimensional matrix, and then basically we will have integer I equals to 0, I is less than m, I plus plus for rows. For columns, j equals to 0, j is less than n, and then j plus plus. Okay, let's say we are having some helper method that will tell us whether word exists or not, right, in the grid. So what we will do, we will pass here the board, right? We will pass the row and column number, and then we will be passing the given word as well. Once this method returns true, then what we are going to do, we are going ahead and return true here as well. Otherwise, in the end, let's go ahead and return false. All right, now let's go ahead and implement this method. So this is going to return boolean, and this is like if this word does word exist, right? Char board integer, let's say this is row number, integer this is column number, which row and which column it is there, right? And then string word. I forgot to take another int, that is index. Basically we will keep incrementing this counter as well. Let's say initial it is 0. So this would be like for the true case. Let's say if index equals to word dot length, then it means we have to return true, right? Otherwise, let's handle the base condition. What are the base conditions? These are for the false conditions. Let's say if these row and column counters, they are crossing the boundary of the matrix, right? So if it is less than 0, if it is greater than m minus 1. Similarly, if it is less than 0 and column is crossing the boundary greater than n minus 1, or let's say this word dot char at index, if it does not match to the matrix, right? That's what we were checking here on the whiteboard, right? So if this particular word, let's say we are coming here, if I undo couple of things here, right? So after C we were coming here, and then it was not matching with the second C, right? It was not matching with this C. So then we were coming back to the C, and then we were exploring the next direction. So that's what exactly we need to check. Okay, if word dot basically char at index, if it does not equals to bold row column. Okay, so I don't know why this tooltip is coming, but it's fine. So, and what else? What are the other base conditions here, right? So let me close my other browsers. Maybe that might solve this tooltip issue. So yeah, that's gone now. All right. So if this character does not equal to this character in the matrix, then basically it is false condition. I don't know. I'm not sure about the other conditions. So let's close this condition here, and then let's go ahead and return false at this point. Okay. All right. So now let's take this character C, bold row column here. So this is the character, right? That we are going ahead, because it did not hit the base condition, means it is the valid character. It is matching with this word, right? If it is moving ahead in the same direction, right, then what does that mean? It means like it's keep matching. So what we can do, we can mark it as a visited, and here for the visiting, we can either take the matrix, basically boolean matrix, right, and then we can just mark it true false kind of things. Basically if it is true, basically we can mark it as a true if it is matching, and if it is false if it is not matching, right? By default it will be false. But here I think we can use this condition. It's saying bold and word consists only of lower and uppercase English letters, right? What does that mean? It will having only the English characters. So we can use any special character that's not going to use in the board, and we can see, okay, we can say, okay, then this, if we encounter this special character, it means it is already visited, right? So if let's say if row column, let's say I'm using any character here, percentage or anything, okay, or maybe a star, okay. So if I am hitting basically this condition, so let's say if my board row column, if it is equals to star, right, then basically I also consider it as a visited. I am not going to do anything because I don't want to basically traverse one cell again and again, and itself it is basically, it has been given in the problem itself, the same letter cell may not be used more than once, right? And that makes sense for the depth first search. Now what we are going to do, we are going to call the same method again, right? Because it is the recursive. Depth first search means we are using recursive solution here, column word and then index plus 1, right? And then let's go ahead and call this for all the 4 directions, because it is horizontal or vertical. What does that mean? Horizontal vertical means it can go left, right, up and down, right? So let's go ahead and do that. So row plus 1, row minus 1 is above direction, and then let's go ahead and column plus 1 is right direction, column minus 1 is on the left direction. Okay, very good. So let's say we are moving all the 4 directions, right? And because this is having the boolean, so I need to return something, some boolean value. How I'm going to return boolean value? So let's go ahead and do this. Let's assign this some boolean flag here, boolean does exist or something. Okay, so let me drag this guy here, and then let's use the or. Why I'm using or, I will explain this in a little bit here after making this code change. So now let's come to here. let me do tab basically to make it a little bit aligned here. Okay, so why we are using or here, right? The reason we are using or here because we want to traverse each and every direction, right? So first of all, we will go deep in one direction. Let's say row plus one. Row plus one means is the down direction. Row plus one means we are incrementing the rows, so it will go to the down direction. It will keep going the down direction because it's calling recursively. It will call again and again and again until it hits the base condition, means it will return false, right? If this particular condition or this particular method is returning false, it means we need to go to the second uh, does word exist, right? Second call. And what does that mean? Second call means it will go to the up direction. Here row minus one means up direction, we are decrementing the row. Similarly, column plus one, we are going to the left direction, right? Column plus one. Column minus one, we are going to the right direction, left direction. So column plus one is right direction, column minus one is left direction. If we are going down, this is down direction. If we are basically incrementing, if we are decrementing, then basically this is up direction, right? If we are decrementing the rows, if we are incrementing the rows, this is down direction. If we are decrementing the rows, we are going basically, then it is up direction, right? So incrementing is basically this is 0 and then 1 2 something like this, and this is 2 1 0, right? So that's why we are decrementing for the up and then we are incrementing for the down direction. Similarly, we are incrementing because this is the column is 0 1 2, so we are incrementing here, we are going to the right direction, and similarly 2 1 0, so we are going to the left direction for the column wise. All right, so that's what we are doing here. And similarly, it will go into the same direction again, right? And then it will check, okay, row minus one, and then it will recursively call, and then again basically what it's going to do, it's going to do the same thing, right? So because row plus one basically we already explored, right? So let's say row plus one is, if we already explored the down direction, then basically the next direction we have to traverse, right? So up direction we will be traversing, we will be checking, okay, if there is anything or not, right? But if we are going to the down direction, we are not going to do the up direction. The reason being that it will again hit the base condition immediately because it is already visited, right? So if I undo couple of things here, we can try to understand this little bit here. So let's say we are traversing this A B C C E D, right? So if I am making the move from A to B, right? So from B, I can make the decision, either I can go to the this direction, right direction, or I can go to the basically down direction, but I cannot go to the left direction, this left direction again, right? Because this is the direction that I'm coming from, right? And it does not make sense to visit the same cell again, right? Because I already coming from A, then why I will come to the A again? It does not make sense. That's why I'm saying, even if it is going uh, row plus one going down, and then if it is going to the up, it is immediately be hitting the base condition because it will be visited, right? It will be the visited cell, right? So basically at every cell it will be having the three choices, right? So let's say my cell is this F or C or something in the middle, right? And if my recursive call coming from the above direction, then it will having the three options. Either it can go left, either it can go right, or it can go down. So these are the three options this F cell is having to make a move, but it cannot go to the up direction. Even if it is going to the up direction, I'm saying that it will go to the up direction, but it is immediately going to hit the base condition because this cell we already mark it as a visited, right? The only way it will go to the up direction once this F is basically is not valid cell, right? If F does not match to the current character in the word, then it will go to the up direction, and then it will undo that visited thing, and then it will traverse the next direction. So that's the only case it will go back, otherwise it is not going back, right? So after doing all this recursive call, we need to undo that visited thing, as I explained earlier, right? Why we need to do undo visited thing? So see, we are storing this current character, and then we are marking this as a visited, and then once all this recursive call is done, then we are undoing this this visited thing in case we did not find any eligible character, right? And here we are returning does exist. So this is the same case that we have seen here, right? So basically, let's say if it is, let me maximize this guy a little bit here. So this is the same case. Let's say if we are basically starting from A, and then if we are going to this direction, B is also matching, C is also matching, and then E does not match with second C, right? E does not match with second C. A, B, C basically was matching with other characters, right? So E is not matching with second C. Second C means this C. All right. So then what it will do? It will go back, right? It will go back, and then we mark this C as a star. It will undo. So it will again replace a star with C, and then it will choose the next direction. Okay, so let's say it chooses the next direction, basically let's say opposite direction. If it chooses the next direction to the left side, then it will say okay, it will again hit the base condition. It cannot go to B because it's already visited, and in the base condition we are checking, okay, if it is already star, then let's go ahead and return false. So it will return false. Then let's say it's hit the, basically its remaining direction is this guy, down direction, right? So the down direction basically this C, and then it will match. Okay, C is matching with the second C, very good. Then it will go down itself, and then E is also matching with the E, right, the next character in the world. And then let's say and then once it traversing each character, it is marking it as a star as well, right? So if I choose the different color here, then this yellow color is, you can consider it as a star. Okay, all right. So let's say if it goes to the right direction, and then this is E, another E, so another E does not match with the D, then what it will do, it will basically go back to E, and then it will undo this star thing. So you see that yellow mark has been removed now, means this star will be replaced with E again, and that's what exactly we are doing. So board row column equals to C, that's what we are undoing, this star with the actual character here. All right, so now we replace star with E. Then basically we need to explore another direction, right? So once we undo this thing, right, and then it will come back to again, and then it will check, okay, E is still matching with this E, right? So E is still matching with this E. Then again it will mark it as a visited, but this time it will explore different direction because this direction already explored. So now the only remaining direction is this left side. So it will go to the left side, right? It will go to the left side here, and this also it will mark it as a visited, right, because it's matching with the D. And also at the same time it will say, okay, index also equals to the word dot length at this point, so it will return true. So that's how this code should work, right? Let's quickly check for the compilation error if there is any, and let's go ahead and correct those issues. So cannot find symbol m-1, that makes sense. So m and n is in this helper method, not here, right? So let's go ahead and correct that. Board dot length -1, and this is also column board 0 dot length -1. All right, let's go ahead and compile again here. So looks like this is compiling fine. Quickly, time complexity wise, would we m into n? Definitely, because we are traversing this whole matrix, and also we are doing the recursive calls, and every cell is having three options as I explained earlier, right? Because it cannot go back to the direction that it is coming from, but it will choose the other three directions at very high level. If we see, then it will have the four options, but in actual, basically, even if it is going back to the same direction from where it is coming from, it does not make sense because that direction is already explored. So in actual, it will be having three options. So basically this will be having 3 to the power L. Here L means is the word length, right? So let's say my word length is L, then it will be maximum going to L times 3 to the power L times 3 directions, 3 options. And to the power, if we say to the power n is here the word length. So similarly we are taking the variable L, that is the word length here. Similarly, this space complexity would be L, L is basically the word length. So in the worst case, we are traversing each and every word, right? Basically here. So whatever the maximum word will be there, I mean, the word length will be not the maximum word, but the actual word length, right? So here, if we are considering A, B, C, C, E, D, space complexity wise in the recursion, even if it is going back and forth due to backtracking, but in actual, in the implicit stack is going to maintain this length only, right? So that's why it is the word length, it will be the space complexity. Let's go ahead and submit this code and let's see if it is going to work or not. So looks like this is working fine. So you see here, this is kind of misleading. So we cannot trust absolutely that this percentage is fine once you submit it again and again. So see here, it started from basically some 50 percentage, then 60 percentage, and now it's 90 percentage. So let's not worry about that too much. Let's try to grasp the concept. What is the concept and how it is going to work? If that is clear, then I think it is fine. So very quick summary before ending this video. This is the 2D grid that we need to traverse to find this given word. The way we will be traversing 2D grid is the same way. We will be using two for loops here, and that's how we are just keep passing row and column number to our recursive method. This recursive method is having important base conditions, and that base conditions are basically if it is going out of boundary or not, right? If it is definitely, if it is crossing boundary, that should be false, right? If it is returning boolean. So if it is matching the case, if it is not, if it also does not match the character of the given matrix, then also it is false. If it is matching, then let's go ahead and mark it as a visited, and here we are using this condition basically. So it says that it uses lower and uppercase English letters. We already know that it's English letters, so that's why we are using the special character here. But if you feel comfortable with maintaining two-dimensional Boolean matrix, that also a good option. Basically, that's what we can also use, right? That does not harm anything. But here we are reusing the same matrix and we are marking it as a special character, and same thing we are mentioning here as well. If it is a special character, then it means it's already visited and go ahead and return false. Otherwise, we are just exploring all the four directions one by one. We are using OR here so that basically if one condition is false, it can jump to the next condition. If it is false, then it can explore the next direction. If it is false, then it can explore the next direction, because we want to make sure that we are exploring all the four directions, right? Even if in actual we will be exploring remaining three directions, right? We are not going to explore the direction that we are coming from because that's already visited, right? So that is the main idea of the this problem. And of course this part is also the backtracking. So even if we did not find the character, then we have to go back to the previous cell and we need to undo that visited thing. So we mark it as a star, and then we need to update with the actual character, the previous character that we stored here in the C character. And in the end, basically whatever the flag is saying us true does exist, and we are returning that does exist. And once we find that index is equal to the given word length, then basically that is a success case. So in that case we are returning true, otherwise we are not returning true. We are just going in the recursion in the depth first search manner, and then we keep searching the word, right? So that is the main idea of the problem. Hopefully it makes sense. If it does not, if some points are not clear, just feel free to comment out, feel free to give your feedback, and I would try to improve on. Thanks a lot. Have a good one. Bye.